Welcome back, ladies and gentlemen. This is going to be the Algebra 2 Function Foundations, Lesson 3, Function Composition, Home Review, Part 3. In the last one, we ended with a word problem, which I made an error for, and I apologize that happens, but hope we fixed it. And I guess why did I leave errors in my videos? No. I guess I wanted you guys to understand in this case that even as a math teacher, I make errors, and we have to kind of look back at our answers without, and see whether or not they make sense. And so in the last problem, we would have had a negative value in our square root, in our radicand for square root, which is not allowed. So I knew in this case that there was something wrong with the question itself, the way it was set up, and I left out a variable there. So once we fixed it, it worked out okay. Okay, so now why is this important? Well, a lot of you who are learning this material will make mistakes as well too. And if you see a mistake and something doesn't make sense, it doesn't hurt to go back and check. It's actually kind of a good idea, especially as from a math student point of view. In anything you do, you always want to check your work and see whether or not you made an error and go back, because we get used to just kind of plugging mindlessly into a function, just plug into a formula, we don't know the value of the work we do. Okay, so we have to kind of think back and say, if something looks off, let's go back and double check though. Okay, and hopefully that's something you also learn when learning about math or anything you do. Does it make sense? So question number 7, another word problem. Physics students are studying the effect of temperature T on the speed of sound S. They find the speed of sound in meters per second as a function of the temperature in degrees Kelvin K by S of K is equal to the square root of 410 K. This means in this case, the speed of sound is affected by the temperature, Kelvin units, which in this case are absolute value, absolute temperature units. No, we use this for more in science than anything else. So the degrees Kelvin is a function of temperature in Celsius given by K of C. All right, so here K of C is C plus 273.15. So we want to find the speed of sound when the temperature is 30 degrees Celsius and round to nearest tenth. So we're going to now find, in this case, we're going to find K of C, and that result will go into S of K. So in this situation, as a composition of functions, it's going to be the inside function is K of C, and then the outside function will be S. And our C value is going to be 30 degrees. So it will be very similar to how we set up before. Okay, so now we'll find K of C, because that's the inside function, or in this case, K of 30 is going to be parenthesis 30 plus 273.15, or K of 30 is equal to 303.15. Okay, now this result will end up going into S. So again, S of K really is going to be the square root of 410 times K, whatever K is. Therefore, S of 303.15 is equal to the square root of 410 times 303.15. Now let's bring out our calculator. We see the work from the last problem here. Let's clear this. So the square root of 410 times 303.15. And we multiply this and get square root of that value. We're going to get 352.5499965, and so we're looking for nearest tenth. And therefore, nearest tenth means that we're going to look at the 352.5, and even though it says 49, we're not going to round and round again. the 4 is what we're focusing on, not the 9s afterwards, but the 4. That will mean in this case, the nearest 10th, the number of 0.5 does not change. So we get 352.5, and so the units would be meters per second. Okay, again, this is to the nearest 10th. All right, and so because it was 352.54, okay, because 352.54, that 4 was not high enough to round the next number up. Okay, even though we attempted to round and round and round again, we have to look at the immediate number to the right of the number we're rounding to. In the hundreds place, there was a 4, not enough to round up. Okay, so just in case you want to get the full page. Question 8. So now we're going to find, in this case, I'll make this page width now. Consider the functions f of x equals 2x plus 9, and g of x equals x minus 9 over 2. Okay, and so now we're going to calculate g of f of 15, so that means f of 15 first. So f of 15 is equal to 2 times 15 plus 9, which is 30 plus 9, or 39. This value will go into g. So now we're going to take g of 39 is equal to 39 minus 9 over 2, which is going to be 30 over 2, which is 15. Interesting. Okay, let's take a look at g of f of negative 3. So f of negative 3, so f of negative 3 is equal to 2 times negative 3 plus 9. That's negative 6 plus 9, or 3. Now, let's take this and plug into g. So g of 3 is equal to 3 minus 9 over 2. That's equal to negative 6 over 2, which is negative 3. That's interesting. So the first one ends up being 15. So g of f of 15 equals 15. And g of f of negative 3 is negative 3. So now we'll do g of f of x. Well, okay. So f of x is 2x plus 9. And this will now go into g. Okay, and so now for g, let's make this green. So g of 2x plus 9 is going to be parenthesis minus 9 over 2. Well, we're going to plug in 2x plus 9, but 2x plus 9 minus 9 gives me 2x. Over 2 means x. Interesting. We just get back x. So these functions, the combination of these two functions, give us back the number we plug in. So when we see d, what appears to be true when you compose these two functions, no matter what, our response will be the result of the composition of the functions will be whatever we input. Okay, so in this case, for A, we input 15 and got out 15. For B, we input negative 3 and got out negative 3. For C, we input, in this case, our input was x, and we got out x, the same exact variable, which would make sense for the numbers now because we end up getting the same thing we put into this. Now, what happens is, in this case, we have not discussed something called inverse of a function. And so the inverse of a function, which we'll hopefully talk about later, is going to be where we are going to switch x and y and solve for y. So imagine this case we had y is equal to 2x, I believe it was plus 9, yes? 2x plus 9. So the inverse means we switch x and y, and we're probably going to do a lesson on this, future lesson. So if you switch x and y, you're going to get, in this case, x equals 2y plus 9. Then we solve for y. So here, you solve for y, subtract 9 on both sides. And we're going to get x minus 9 equals 2y. Divide both sides by 2. Y is equal to x plus 9 over 2. And this is going to be g of x. So f of x was equal to 2x plus 9, and so g of x is what we call its inverse, okay, if we switch x and y. So what it comes down to is if you take the composition, and so we'll kind of fill this in this case, if we take the composition of a function and its inverse, we will get back what we input. Okay? So you plug in x, you get back x. Plug in -3, you get -3. Plug in 15, you get 15. And so this is the result we have. So we said before, and the funny thing is this, if we reversed it, we would find we get the same result. Here is that situation we said before that a composition is not, the composition function is not commutative. Well, it is not normally, but if under one situation where it will work out, and by the way, if it works out once doesn't mean it works, that's true for everything. Okay, so quite the opposite. If it fails one time, then we can never say it's true for all of them. So, but we do see it does work out under the one condition where you have a function and its inverse. Okay, so this is kind of interesting how we do this nowadays, gentlemen. Hopefully it was helpful to you guys. And so this is the end of our lesson for composition of functions. So, however, you know, it's more practice because we see a lot of this. A lot of times we see functions within another function and another function, and we'll do a lot of this later on. So it's a really good idea to be able to be practicing and be very good at how we do these things. Okay, so it's kind of a build on top of a function notation lesson from lesson 2. Hopefully you guys have was helpful. Please leave a questions or comments and feedback in the comment section below. We appreciate you watching. Please give it a like if you found it helpful at all. Appreciate that. It really help us out. And if you have not subscribed yet, please do so. Turn notifications so that you will be notified when new videos are added to the channel, especially our new Algebra 2 videos. Okay, so hopefully this is helpful, and hopefully you expand your knowledge of Algebra 2. We move on to our next lesson, and you'll find in this case, as we continue with each lesson, they get heavier and heavier, but well within our ability. Okay? Thanks so much for watching. Take care and be safe.